Diethyl ether is a pretty commonly used solvent in solvent extractions and Grignard reactions. It's pretty volatile and boils at only 35 degrees Celsius. It's pretty hard to get access to it because nobody really sells it. This is because diethyl ether tends to form dangerous explosive organic peroxides due to exposure to moisture and light. So it really can't be stored, and the only way to access it is either to synthesize it yourself or to extract it from industrial products which already contain it. I'm going to be doing the second method, and I'm going to be extracting the diethyl ether from some starting fluid, which is commonly used to make car engines start in cold weather. First, I sprayed out the contents of 3 cans of starting fluid into an Erlenmeyer flask. Quick note, the Erlenmeyer flask is going to get really cold, as the spray that comes out is going to get super cooled by the air. Once all the cans had been emptied, I poured the contents of them into a large round bottom flask. To extract the diethyl ether, we're going to be performing a fractional distillation. That column thing you see on the left is a fractionating column. It's used to separate solvents and liquids which have very similar boiling points, which is important in this case because the diethyl ether in the starting fluid is mixed with other solvents. So we need the fractionating column to get pure diethyl ether, otherwise our ether will be contaminated with the other components of the starting fluid. Once all the liquid was added to the round bottom flask, I turned on the heating mantle and set the temperature to around 50 Celsius. I also turned on the magnetic stirring, which prevents the ether from boiling too vigorously. The metal wire you see on the left is part of my digital thermometer, which I use to monitor the temperature of the heating mantle. It's important to use cold water in the condenser, because since ether's boiling point is so low, room temperature water is not going to condense it efficiently. Unfortunately, I don't have access to my water pump, so I have to manually add cold water to the condenser and replace it every few minutes. This is a huge pain, and I don't recommend anybody doing it, so make sure you have a water pump which circulates cold water in the condenser. The orange tube you see from the end of the vacuum adapter to outside the window is used to avoid breathing in any ether vapors that might escape. As you can see at the end of this tube, you can see the ether vapors coming out of the end. This is why it's important to have a tube leading outside to avoid breathing in solvent vapors, which are not very healthy. I also insulated the fractionating column with some aluminum foil to keep the heat in. After a bit of heating, we can see some liquid dripping into the collection flask. The vapor temperature is still below 30 degrees Celsius, which means that this is not actually diethyl ether, and it's some other product that was in the starting fluid. So we collect all this liquid that boiled over below 30°C, and we discard it. Once the temperature in the thermometer reaches around ether's boiling point, which is around 35°C, we get rid of the liquid that we already collected and start collecting some pure ether. Here's a quick little time lapse of the collection of the diethyl ether. That brown stuff you see under the round bottom flask is just paper towels which I soaked in cold water. This is done to keep the ether cool and preventing from evaporating. As the thermometer's temperature rose, this signaled the end of the distillation. As you can see, there's still a bunch of liquid in the distillation flask, and this is just the other products that were in the starting fluid. So I turned off the heating mantle and let everything cool down. Here's our final product of diethyl ether. I poured it all into a properly labeled dark glass bottle for storage. As I mentioned earlier, diethyl ether tends to form peroxides over time. So to prevent this, it's usually stored under sodium metal or sodium hydroxide. Very little is needed, and you just need a small crystal of sodium hydroxide added with the diethyl ether. And here you go, diethyl ether from starting fluid. I hope this helped, and I'll see you next time.